Un momento de su atención. Yo soy Paulina Martínez, la gerente general de la Cámara Chilena Australiana de Comercio. Les quiero dar la bienvenida. Muchas gracias a ustedes por asistir a la hora, que es algo importante para nosotros. La Cámara de Comercio está muy contenta de poder colaborar con Dingo, empresa australiana que está entrando en el mercado chileno. Solamente darles las gracias. Estamos con Latinoamérica conectados, también a través de streaming. Les quiero recordar a la gente que nos está escuchando en Latinoamérica de que las preguntas van a ser realizadas al final de la oratoria, y lo mismo para ustedes aquí presentes. Lo voy a dejar con Alex Pasaño de Queensland Government, que va a hacer unas palabras. Gracias.
Gracias, Paulina. Bueno, bienvenidos todos. Mi nombre es Alejandro Pesaño, representante comercial del estado de Queensland, Australia. Primero que nada, muchas gracias a la Cámara de Comercio Chileno-Australiana por esta oportunidad, por dejarnos usar las facilidades de ustedes.
Kerry, en realidad.
Kerry, gracias Kerry. Trade Investment Queensland es una agencia de gobierno del estado de Queensland, Australia. Tenemos una oficina acá, basada en Santiago, y desde aquí cubrimos toda América Latina en la promoción de compañías de Queensland, a desarrollarse aquí, a traer sus productos. Tenemos aquí dos personas de la oficina, que es Sebastián Tobar, allí en la mesa, y Marco Miranda, que está en la puerta. Al final de la presentación, si necesitan alguna pregunta, por favor, se acercan a ellos. Hoy tenemos una compañía que se llama Dingo. Dingo va a hablar de la optimización de los activos mineros. Es una empresa que ha estado muchos años en el mercado, una empresa que se ha comprometido a entrar aquí en el mercado en Latinoamérica, tanto así que el Business Development Manager para Internacional es un colombiano, que es Carlos Pérez. También quería comentarles que quería presentarles al CEO de la compañía, Paul Higgins, que nos va a hacer la presentación hoy. Desde ya, muchas gracias por haber venido hasta acá, y les agradezco a ustedes mucho por la presencia. Gracias. Paul.
Thank you. Well, welcome everyone. We're very pleased to be here, and I'm very grateful for the attendance of not only people in this room, but about 80 people who have signed up for the live streaming of this presentation today as well. So it's a privilege to speak to an audience such as this, and we very much appreciate it. We know everyone's time is available, and the traffic in Santiago is not favourable. So our team has put a lot of thought into what we will show you today. We're very passionate about this topic. We've put 25 years of our business has been in existence into mining, and we all know that right now are very, very challenging conditions, but mining people are tough people, and they figure things out and they keep going. So that's what it's all about in the industry today. So hopefully in this beautiful room, in this beautiful city, we will be able to today share some good news about some possibilities in an industry which of recent times has been receiving a lot of bad news. I'd like to add my thanks to the Chile Australia Chamber of Commerce for assisting us putting this together today. For Trade Investment Queensland, who were very helpful in exposing us to the mining industry in Chile in October last year, and continue to assist us here today. And thank you, Alex, for the introduction. And also to Carey Law Firm, whose beautiful boardroom sits in front of me here. I think this is the largest boardroom table I've ever seen, so you guys are obviously paying them very well. So we are using a lot of technology today, so bear with us if any of that doesn't cooperate as well as it should. First of all, I'd like to just introduce you a little bit to Dingo. This is not so much a commercial, but just to say we're relatively new to this market, so we did want to tell you a little bit about who we are. Who is Dingo, other than an Australian dog? So we are an Australian company with offices in Brisbane, where we started, and Denver in the United States, where we serve the mining industry of North America. We were born in the mining industry in Australia, and we have expanded to other asset-intensive industries, such as oil and gas, wind, renewable energy, and automotive rail, heavy haul rail and freight rail systems. Today, over $7 billion worth of assets are managed by using our tools and services on a daily basis. We have 166 operations that are under our management, including many large mines, some of the world's largest. Unfortunately yet, none in Chile. However, we hope to change that. We have over 100,000 components in our asset database, and when I use the word component, I'm referring to a large diesel engine, a turbine, a large gearbox, transmission, wheel motors, those sorts of things. The cumulative total of the savings that have been achieved by our partnership with customers to this point in time is $275 million, and that is parts only. It does not include any availability gains, downtime, production increases. And those numbers have been the formulas used to calculate those savings numbers have been validated by John Sturmel of the Colorado School of Mines, who is the world authority on mining economics, and I'm sure some of you here have been trained by John. So the next slide up will show you some of the partnerships that we've formed with customers over time. Some of our customers, we build long-term relationships with customers, and we're proud to welcome several Latin American sites recently, including Core's Palmarejo mine in Mexico and the latest Sabosi in Bolivia. Right. Turning now to what some of the challenges our industry faces, and I say our because we're all in this together. I attended Mining in Indaba in South Africa earlier this year and heard MARC Kudafani speak, the CEO of Anglo American, and this astounding figure of the loss of value of the stocks of mining companies globally since 2011, almost $1.4 trillion in value, gives us all reason to pause. But with all that news, the reality is that the fundamentals of the demand for the minerals that the mining industry produces globally is still strong and will remain that way. There are 72 different minerals in an iPhone, and there's a lot of them that your children are buying, so the demand for our minerals continues. There's a lot of losses happening in the industry. Of course, loss of revenue. These are numbers that are unfortunately true. Profitability of mining companies down 61%. We're considered the business sector that Dingo participates in is METS, Mining Equipment Technology Services, and a report last year by our industry group showed that the 59% loss in customers and projects. So it's tough times out there. Productivity has been just going this way. Productivity, of course, has taken a strong hit for a long time, as very buoyant prices meant that buying more equipment, adding more people into the cost structures of mine was a very good business practice. There was that's a very legitimate expansion strategy when prices are very high, and most companies took full advantage of that. Unfortunately, the legacy of that is that those cost structures are now not supported by buoyant prices, and so productivity has just continued to decline. I remember back in the boom days, 2007, 2008, I would visit senior mining executives in places like the Pilbara, and the only question that they had for me was, do you have any tyres or do you have any people? Because that was all that was really needed at that time. Those were the constraints on the industry, but today it's very different, as we all know. I like Albert Einstein a lot. His face is going to come up on the screen here shortly, I hope. And I don't like him because I had to study the theory of relativity in Year 12 physics. But I do particularly like his ability to speak to the human condition that faces us. And this is one of my favourite quotes of Albert Einstein. That is, we can't solve the problems that we have with the same thinking that went into creating them. And so, with no disrespect to the past, I would highlight that we need new thinking in mining to address the challenges that we face in front of us. Many CEOs of mining companies that I talk to see collaboration as key to their success. They know they can't solve these problems just with internal resources. They need to partner with outside expertise and to close some of these gaps that have occurred in productivity. So what are some of the ways that the Latin American and global mining industry has dealt with some of the challenges in the past. MARC contracts effectively pass the risk of maintenance costs to the OEMs, but at a cost. They are expensive. What we call DIY, do it yourself, developing internal teams to build out that capability, or contract mining, actually having somebody else do the mining for you. Those are all being challenged dramatically now, and I think that represents some of the thinking of the past. So our challenge is, how do we think about things in the future? Our belief and some of our experience is that in the area of asset management and reducing costs in maintenance, the ownership of that task, where the rubber meets the road, is really at the mine site. People actually doing the work. What is the underlying objective? In the old way, under dealer programs, the traditional supply chain, and that is evolving. To the credit of the supply chain, it's evolving as well, for sure. But the objectives before were to supply parts and service efficiently for the profits of the dealers. Of course, they're in business too. In the corporate-led programs, a lot of the idea was what KPIs do we need to control and understand what's going on at the sites. So what we believe is the new way is that the mine has KPIs, the key indicators, that it needs to be very efficient and effective. It needs to do that in a low-cost way as well, keep the total cost of ownership of those assets down. Who has control? Who needs control? Should that control rest with a supplier, or should it rest more so with the mine? These are new ways of thinking. Sure, a dealer program is very easy. It's well organised. The complexity is low. By contrast, building an internal, large internal group, getting all the tools together, that's a very complex operation, and we've seen a number of them fail. And in this environment, with pressures on staff numbers, often those groups are the first to be disbanded, leaving a hole in what was the maintenance delivery process. So, by contrast, the new way of thinking must be, how do we take complexity out of the system and make it simple to get good results quickly. The impact on cost per unit, anything, of course, that is more expensive, like building in and protecting risk by paying for it, that adds cost. That is, we see around the world now, fleets transitioning away from MARC contracts, for example, and into owner-maintained, and with an obvious goal of reducing costs. So that's some of the new thinking. I'll just calibrated the slide pace now. No, that's fine. That's fine. Oh, can everyone see that okay? So this is with data, you can answer the question, where am I now? Where do I stand if asset health is going to be an important part of this new thinking, where do I stand right now? And you can answer those sorts of questions with facts. We need to answer those questions with facts. So this is an example of where a customer has supplied data to us. We compare that data against a global data set and then present, often for the first time, a clear picture of what is the status of the health of those assets in that mine site for the first time. So in this chart, for example, along the bottom axis are groups of assets: trucks, shovels, dozers, loaders, excavators, graders, drills, the sort of things that you'd find in a typical mine site. And then the green bars are the percentage of assets in that class that are operating in a normal condition at that point in time. The yellow is that they're in some sort of warning state, and red is that they're in critical condition. So the overall for the site there, this site, half the assets were operating in normal condition, about 40% were in warning state, and 20% in, or 10%, sorry, in critical condition, meaning that $20 million worth of assets were actually at serious risk. By comparison, the best of the best in our database, more like 2% of those assets are in critical condition, 10 in warning, and a lot more operating in normal condition. So that gives you a picture of you can establish today, where am I in my asset health, very quickly. That exercise is not a lengthy exercise because of that large database that we have to compare. This is, I think, a very important aspect as well, which is getting the right mix of the human interaction and technology. So this is an Ernst & Young chart from 2014, and it shows the ease of execution of change-oriented programs along the x-axis, and then the impact on the y-axis. So, faced with catastrophic collapse in commodity prices, what is the first lever that most mining executives pulled? And it is the supply chain reset. So that, if we want to just speak in plain words, that means go and ask your suppliers for a discount. The second major lever that was pulled, and again now we're up to a year in because it takes time to pull this lever, is the lever of manpower reduction. And I have heard stories, even in the week I've been here and prior, my last visit, that obviously Chile is and Latin America is experiencing exactly the same phenomena that we're seeing everywhere in the world: layoffs, reduction in staff levels. That's very painful. It affects people and their families, but it is a lever that is one that has been used to reduce costs. The third lever is capital, a reduction in capital expenditure, and that again takes a longer time, but it has a higher impact. That's sweating assets and talking about making decisions about not spending capital, and that's obviously been flowing through. I think Chile's capital phase, Latin American capital phase is probably a little bit behind the rest of the world because copper prices stayed stronger for a bit longer. And so that brings us to the next major lever, which is the human technology interface. This is getting technology and people to work towards those goals of productivity. This is implementation of new tools, new software, new systems, new ways of doing things. And this takes a bit longer. You can see there the time frame is about 2 years. But look also at the magnitude of the impact. And this is the space that we believe that Dingo operates in, and that is now emerging as the big opportunity that we see for mining companies today. So what is our approach to the human technology interface? How does Dingo do this? Our approach is that we gather the data that is needed to make informed decisions. All sorts of data, not just, we hear a lot about sensors, and we all know that a modern mining piece of equipment shows up with the capability to generate a vast amount of data. I think the last statistic I heard was a new haul truck generates 275 gigabytes or terabytes of data a day. So nobody can handle that. But there is a lot of data in mining operations that is underutilised today. So why not take advantage of that? There is data from sensors. There's operating data, such as component hours, how many tonnes have been mined, the hours that the machine's been running on its current lubricant, things like that. Then there is offline condition data, things like when the vibration guys come and do a survey at the site every quarter. The oil samples that get taken from mining equipment and sent off to a testing lab. There's a lot of that data that is very underutilised. Of course, there's the maintenance history of those machines as well. We call that the ERP work order history. The work history from systems like SAP and Ellipse and others. And then there's inspection information as well, including visual inspections. So all that data, our view is there is no real need to go out and produce a lot more data. There's enough there to take advantage of today. The question is how to do that. And our process is simply defined like this. The red truck up at the top is one of those ones in the red bar in the chart before. It's in critical condition. It has data associated with it. It's spitting out information, maybe from sensors, maybe not. We take that data into one single global cloud-based database. Then we have a team of analysts who use our predictive analytics software, trending tools, and a library of other intellectual property, troubleshooting guides, comparisons to our database, to provide actionable knowledge in the form of a work request. This is what looks like the emerging problem, and this is what to do about it. It's not just go and, there's a bad piece of information. It's a very, very specific recommendation. It might be a coolant entry has started to emerge on a 3516 Caterpillar engine. Go and do this specific pressure test on the manifold. The whole goal, of course, is to bring that asset back into the heart, the nice operating condition that it was designed for. So that's our collect the data. That's our process of adding value to that data, and then sharing that data at the appropriate level with the appropriate people through technology. So we have a technology stack which consists of our tracker software, which is the central repository for all that data, and then a dashboard which we developed with some of our senior mining executive customers, a dashboard which enables a very easy view of asset health on a web through a simple web browser, even a phone, and then at the site level we have our iPhone app, and it actually works on Android. It's just a smartphone app that enables people that work at the mine sites to contribute data up to the analysts. And also our development pipeline will mean that they will be able to receive those analysts' recommendations on their phones as well. So what does this end up doing? I was talking to a gentleman earlier, talking about the availability was one of the critical aspects that he and his team were working on. So this is real data from a customer site, and why we are so passionate about bringing this forward. This is the trend in overall asset health for a group of mines actually up in Canada. And as you can see, over a 12-month period, those critical assets were brought back into were eliminated and brought back into a normal operating condition, and that had two powerful impacts for the situation that we find ourselves in today. There was a increase. The blue line at the top of the chart on the left is availability of that fleet, those fleets. And as you can see, it was steadily increasing as that asset health improved. Of course, that makes sense, right? Healthy assets don't break down. Breakdowns, you lose availability. So as those assets get healthier, less breakdowns, availability improves. The other very positive consequence is that because the health of those assets are maintained along the way, they last for longer. So the blue bars indicate the average component life across all of those fleets year on year. And as you can see, it's steadily increasing. So two really big, powerful contributors to the sorts of things that everyone needs in this environment that we're in. Increased availability and longer asset life. Again, we, over 20 years working and believing in this process and seeing it come about and working with customers, we've distilled it down to two core processes. One we call condition management and one we call life cycle management. So what is condition management? It's not condition monitoring, and I've got a slide to illustrate the difference. It's management of the condition of the asset. So what does it entail? Daily monitoring of component condition, recommendations for corrective actions as the condition identifies a potential risk of breakdown and or failure, acknowledging potential failures with lead time to mitigate them and eliminate root cause. It's a critical process that supports life cycle management. So we start with the customer on condition management. Then we move, once that is coming into control, we start implementing the second effective cycle in our approach, which is life cycle management. This increases uptime, maximises equipment use, optimises component life and reduces overall maintenance costs. So it's essentially moving from meter or time-based maintenance to condition-based maintenance. It's changing things when they need to be changed, not on a time interval. My dad had a knee replacement last year, and I reflected on this. You can go to the next slide. Thinking, imagine if the human health industry worked the way the mining industry has worked in the past. We'd all have knee replacements at 70 years old. So I said condition monitoring, condition management is different from condition monitoring. So what does that statement mean? I'll start with condition monitoring. We start with often disparate data stored in different places, vibration analysis data, oil analysis data, thermography, all stored in different tools and systems. Our approach is put that all in one place, so it builds a comprehensive picture. The data is disconnected. It's not linked with critical inputs aren't necessarily used, sometimes because the data's hard to get to or an expert's needed to review it. It sometimes falls through the cracks. So rather than that, bringing the data into creating a holistic view of that. In condition monitoring, often what happens is an analyst will find a problem and say something's shaking, or we've got a bad oil sample, write a work order, and that's where it stops. Our approach is that it's not over until we can prove that condition has been returned to normal. And so that needs validating data and a couple of extra loops, if you like. In fact, in the case of, say, an oil sample-related failure or a problem in an engine, we would wait for 2 consecutive samples to come back into normal condition before considering that problem has been resolved. That's that green arrow from acting to assessment. There's a feedback loop there. So, unfortunately, the result of condition monitoring is often that the assets stay in an unhealthy condition, and that leads to a substandard availability and life. And so they capture some of the pie, but not the whole pie. Our approach is to capture the whole pie. We need that today to be competitive. So assets stay healthy and then perform at their peak level. Now, this slide it looks complicated. I'll try and break it down for everyone. So we all know what we call the reactive workflow. It broke, we need to fix it. This is very basic and it is very necessary. However, just keep clicking, I think, Carlos. The traditional, the next sort of workflow that we're all familiar with is a preventive maintenance workflow. This is very common in, this is the scheduled maintenance approach, where inspections, safety issues, any damage, what's the repair that's needed, the time and meter-based services, performance hours. Pre-PM is often done, that then creates a PM task, going into planning, scheduling, execution, and then the feedback is what was done, what remains to be done, what parts we use. The predictive maintenance workflow adds data and into the picture to start with. So the blue box feeding in is doing extra is feeding condition data into into the predictive analytics and resource center. The analysts that perform a detailed analysis of what is the emerging problems. That also goes into the plan. It's scheduled, and then there's a diagnostic step, which is we think this is the emerging problem based on all the data that we've seen, and maybe some other investigation needs to be done. Go out and physically inspect something, do a test, and then feed that data back in as quickly as possible to the workflow loop. So that is the big difference between a preventive maintenance workflow and a predictive maintenance workflow. There's a diagnostic loop, and we've designed software to manage that extra component of the maintenance cycle. It's very important to understand this as well, because this is disruptive to the way that maintenance is usually done at the site, and it requires a management process to move the teams to the new way of doing things, but it's worth it because it saves a lot of money. As I said, all of the data is available to view the progress of the program through a dashboard. So again, we developed this dashboard with our customers. It brings visibility and accountability to the new maintenance process. There is all of these graphs can be drilled down. You can drill down into the actual individual component level to see what's going on, and you can use it on your smartphone as well. It gives, for example, just going around the charts here, the top left, macro asset health view. What's the health of my entire operation today? What are the top 10 things that are causing problems? What components have been changed recently, and how did we do versus the planned component life? How did we do there? What components are in critical condition? What do we need to keep an eye on, especially if they're critical to production, and components that have got very high hours. So the other little tool that we developed, so that's the dashboard for executive management, and now we'd like to show you something that we're very proud of. We won an award. We developed an application with one of our customers, BHP Billiton, and we won the Innovation Award for mining in Australia last year out of all of the entries for this little app, which runs on a smartphone and enables people in the field to communicate directly with our analyst teams, their support analyst teams. So Carlos is just demonstrating this right now. So that is iPhone. It's bringing up the Dingo field inspection form. It's capturing the satellite because it actually records the GPS coordinates of the inspection. And then you can select the asset group, in this case a reclaimer. We've done an inspection now. Put in the meter reading. What type of inspection or what component are we inspecting? In this case, a gearbox We're doing a visual inspection. And then we'll take a photo of this group. No, that's a bad photo. Okay, so then if the analyst wanted to highlight something just using their finger, this is a leak here or a problem, put in some inspection notes. And then it's located us here on the in the building, and save it, send, and 2 minutes later that is in the cloud. An analyst in Denver or Australia or Santiago could be looking at that, providing that expertise to the customer, to the maintenance technician. They may not know what they're looking at. So that's part of our stack. So thanks, Carlos. So bringing it all together, we think that this approach brings together a number of really important elements. The right mix of human technology. I like to say for the app, for example, there's a lot of talk about sensors now. The human being that's out working near the equipment is probably the best sensor in the world. They've got eyes, ears, a brain, they've got experiences, and using that app, they can they can convey a lot of information. So that's an example of what we talk about with the right mix of human technology. So we collect data now from mine sites all over the world. A team of experts then transforms that information into actionable intelligence, not gobbledygook that people can't understand, but very specific maintenance actions that they can do that day. And they share that across the operation. So you can see the analyst group there and the guys at the mine site receiving that information, putting it into that planning cycle. And that then delivers that benefit that I talked about earlier, taking the truck, gathering the information, applying the knowledge, creating an actionable intelligence and bringing that back into normal operating condition. And we're very pleased to say that this is working, and we've built a very strong partnership with some of the leading mining companies around the world to do this. Newmont was one of our first customers to adopt this approach over 10 years ago, and at the Lone Tree and Twin Creeks mine, a couple of years later, Phoenix and Carlin came on board. Leeville and Midas were two underground mines, hard rock underground mines, and then we got a request to start servicing Barahiju in Niger, which is completely remotely, and Boddington in Western Australia, and the last one to come online is the Merian mine in Suriname, which started just recently. Excuse me. Same sort of progression with Teck Coal at the Fording River mine site, Elfview, then all of their coal sites, and then we were given the opportunity to work with the maintenance manager from Fording River, transferred up to Highland Valley Copper, and he invited us to help with that mine site too. That's Canada's largest open cut copper mine. So with Anglo American, we have a very good working relationship with the coal group, under intense pressure at the moment, and actually for sale. Anyone want to buy? So we've got a very good working relationship with Anglo and also Core. And this is a pattern of companies that adopt this approach, get the benefits, and then continue to want to expand the benefits to other sites. So we hope we can work with some of the companies, form partnerships with some of the companies here in Latin America as well. Case studies are always a nice way to kind of see what the results are. This is a case study from a large open cut copper mine, and you can see there, in this case, we were tracking mill availability, and as the asset health improved from a starting position of 19% of their assets in critical condition up to 1%, availability gains were significant in the order of a couple of percentage points. So again, this is, I have to emphasise, this is not, I'm not saying Dingo is responsible for these results. This is a partnership between our organisation and our customers and others in the supply chain, the equipment suppliers, the suppliers of the mills, everyone. It's a team effort. But when we work as a team, we can achieve fantastic results and all be proud of it. This is one that we're particularly proud of, which was a customer in Canada. This is the average life of their wheel motors on Komatsu fleet, 830 and 930E wheel motors. When we started working with the customer in 2009, the wheel motors were achieving 13,000 hours average life, and now those same wheel motors are up over 40,000 hours in average life. So that's tremendous savings, not only in the replacement cost of those, but the availability gains from not having to replace them as early. So that was $15 million of savings just through the extension of life of those wheel motors. Another thing that we bring to the table is the ability to know what good looks like. So because we've got that large database of asset health information and asset component changes, we can show customers what it looks like. That's similar to those charts before, which were summary charts, but this is actually at the 2,000 hour intervals of component life, a distribution of what's in our database versus what the customer has. So we can show not only in this is Cummins QSK engines on the left-hand side, and the sort of engines that you find in underground equipment on the right-hand side. So we've got a broad database and bring a lot of information to the table. More levers that we can help customers to pull are, and this is something that we've helped a customer with recently, was actually moving significant component changes into a future financial period for cash and financial management. So their early, this was what they were doing before we got involved. They had those major component changes. They were three engine changes and a transmission change, scheduled for August, September, October, $300,000 each, and then $150,000 transmission in December. So using that condition-based approach, we were able to inform the customer that they could safely move those major component replacements into a new financial period, 2017. So those are big levers for the CFO to be able to confidently make those sorts of moves. And if you apply that across multiple mine sites, it adds up. These are just some other results in terms of total savings in a underground silver mine that implemented an asset wellness program. And you can see the different types of savings, the breakdown cost avoidance, and the component extension savings, and then the cumulative total. So the beauty of this program is it can be applied to a small site or a large site. It works just as effectively, and that's something particularly small single mines don't often have access to those big resource groups to help them. So this is very important. This is a long-term, 5-year program and the sort of results that have been achieved over a long period of time. We project those savings in a business case that the executives can sign off on, or and produce the data to validate the business case, and then we go and execute it together. So by working with a proven partner, we hope to bring the sort of gains that we've showed today to this part of the world. And time is of the essence, of course, for all of us. Good thing is this is a fairly rapid program to employ. In essence, we tie together what we've talked about today: listening to the asset, collecting that data into one place, applying the best analytical tools and thinking and people in an off-site remote facility that then works with the local team to communicate exactly what actions need to be taken so that that asset can be brought back into the place that it should be. And that drives productivity, profitability and performance. So we're very optimistic about this, that we can do this whole process better, faster and cheaper than anyone else, and we've got the runs on the board. So we hope to be able to bring that to some of you in this part of the world. So now I'll hand over to Carlos to pause for some questions, and I think we've been gathering some questions from our online audience as well. Thank you.
Thanks, Paul. I think we should be starting with the questions coming from the room here first. So feel free to start firing your questions. Paul will be answering them to you, and while I'm getting some of the questions that we get into the webinar, so we also going to bring those questions live. So we'll see what's the reactions coming from Latin America. So by the way, this being streamed live to Peru, Colombia, Chile, the rest of Chile, Mexico, and Argentina. So there are a few colleagues of ours listening live this. So I'll hand it over to anyone who would like to start the questions.
Buenas tardes. Quisiera saber cómo esto trabaja con la operación, con los operadores, porque esto es un sistema que adopta o toma la información desde los signos vitales del equipo, la muestra de aceite, migraciones, pero cómo los operadores, qué tanto influye la operación en esto, cómo se liga, cómo se une eso.
Julio is asking how the operator, the technician, amalgamates your information with their information.
Yeah, okay. Can we go back to the workflow slide?
I think some of the early slides.
So the information that they would have, their observations at the site, what they're seeing with the asset at the local site, how do they communicate that? That's a great question. Part of the feedback loop is that they have access to the software as well. So when an action is created, they see an open action on their computer and they complete the what they saw and what information they have in that feedback loop. So there is also a integration between our software and the maintenance software system. So when work orders are completed, those can be seen by our analysts as well. So all of the closing, the work order closing comments are seen by our analysts as well. So there's a very much interaction between the people on site and the planners typically, and our analyst experts backwards and forwards.
Hay una metodología que se implementa y se entrena a los técnicos, ¿no es cierto?, que es un equipo de Dingo que ya hace eso. O sea, se implementa una nueva metodología que hace que la gente siga los consejos que le ha mandado la gente. He's referring to the operator, the guy who operates the equipment.
Truck operator.
Oh.
How the truck operator know about this? What is the influence?
Typically, we would deal with the maintenance organisation and any operator conditions that are reported can flow through to the analyst through the maintenance group. That's typically the way that works. So we don't typically interact directly with the operators. But that's not to say that we could not do that. Whoever's got the information, we'll listen to.
Anybody else?
Thank you for the question, by the way. Good.
Hi, my name is Martin Vega from RCT. You've got a huge amount of data, right? What exactly does the human team do in Dingo? If you've got all this data, couldn't you just, given all the statistics, say, now you've got to do this and that to repair your truck? What is the human team? How do they add value to it?
That's a great question. A lot of that interaction comes from, particularly with data that is complex in nature. So, to give you an example of a typical workflow. Say an oil sample has indicated a spike in silicon. Our software will pick that up. It might be a very low. It's not a massive spike. It's just a little emerging thing that could become a problem. So that would then go into a recommendation to say do a filter inspection. That can be go through the work order system, and then the data coming back. What did that person see? Well, they might have some incomplete notes. But if they are like most maintenance people, they're not going to give a lot of feedback. So if they can talk to a person and say, yes, I did see the filter had a problem, there was dirt in it, the filter didn't have a problem, but when I was there, I saw a crack in the housing. That human interaction, and our analysts are really good at software, but they have spent time on the tools as well. So they know how to talk to somebody like them without it being a confrontational conversation. They understand it. I think this is I'm glad you asked that question. It's a really important point because the mining industry is made up of people. Yes. And if we forget the people, we won't succeed.
I guess you've got people in the US, not only in Australia, because they wouldn't be sleeping in Australia.
That's right, and that brings up a good point. We are in discussions with a partner here in Santiago about building a analyst service centre here, because they need to know that unfortunately Chile lost to Argentina in the football that week too. It's those sorts of human connections that build trust. When you're asking somebody to potentially take the keys out of a 5,500 shovel or a $7 million haul truck, you need to be able to trust the person that's making that recommendation. And that takes time, and it's a human-to-human relationship. Great question.
We got two questions. One. Okay, we got two questions coming from other countries, or sites in Chile. One of the questions is how many equipment can be managed simultaneously with Dingo's capabilities?
Well, there is no theoretical limit to that. We have customers that have 2,000 and 3,000 components, is the way we typically consider that. We have a wind customer that brought 10,000 components into the system. So there is no real theoretical limit. We've designed this system to scale from small mines to very large mines.
Thanks, Paul. Thanks to Mr. Juan Abad to make this question. And the second question, if may I, is coming from Carlos Pavis. And he's asking if Dingo takes the data from sensors, from monitoring of vibrations, lubricants, or in an automatized way, integrating into the system. Yes,
absolutely. All of the data that's available, sensor data, is a bigger challenge than because of the volumes. So we are working with the University of Queensland and Queensland University of Technology on pre-processing software to reduce the very large data sets down to manageable sets of data. We are not in the business of looking at alerts that go off in an operator cabin, for example, where we are more on the longer term health trends and looking into the future to avoid emerging problems, to reduce breakdowns and extend the life of components. But the answer to the question is all of that data is part of that picture. And if you, Carlos, if you just go back to the slide, which is the fetch. No, sorry, one dashboard. So this slide here addresses that question. All of the data on the left-hand side is what we would typically collect. So sensors, operational data, off-site data, the work order history from the maintenance or ERP system like SAP or Ellipse or anything, and then the inspection data, and including visual inspections that Carlos demonstrated.
Thanks for the answer, Paul, and thanks again, Mr. Pavis, for raising the questions. I'll just pass it on back to the room here if anybody would like to make more questions.
Paul, when you are talking about that you are able to control 10,000 components or something like that, what is the definition of component? Is that all system?
Okay, so I think the slide was 166 operations is what we would, or sites, is the number that we, and so we would consider a site to be like a mine, or in the case of the wind industry, a wind farm that has 200 assets in it, or a rail fleet. So they're sort of larger groups. Does that answer your question?
Completely. I mean, when you are talking about components, you mean, for example, filters or parts of a machine, or what is the component?
Oh, I'm sorry. I misheard you. Component. A component is a sub just under the asset. So a component, we would refer to a component being an engine, or a diesel engine, a transmission, a gearbox in a wind turbine, a traction motor in a train. That's what. But then again, on the smaller side, a final drive in a wheel motor. So that's what we consider a component.
Paul, you showed some impressive saving numbers your customer have realized, but nowadays, as you said initially, mining is a tough market. What's your typical experience? How fast can you see payback after some initial investment, and then the savings coming in over time?
So, Carlos, do we have a slide in the appendix deck on the time frame?
Yeah, I can bring it up. Yeah.
Carlos is just going to bring up a slide, but I'll just verbally answer that. So, typically, a implementation is 1 month to collect the data, load it into the cloud, and then connect the data sources. Then there's a period on site of a couple of weeks to do some training, workflow, integrate that workflow into the new way of doing it. So, say a total of about six to 8 weeks, and we start doing the analysis of the data usually in the first month, and then that's when we can start, as soon as that workflow is embedded in the new location, we can start taking action on those analyses, and we typically have first saves in a month or two, and payback to where it's the cost of the service is less than what the savings are in between 6 and 12 months. 6 on it if we are lucky and get a big event early on. There's a typical sort of time frame that Carlos has just brought up there, with months on the bottom. So it's a very fast payback, and in this, as we all know, in this environment, it has to be. Unfortunately, we're all under short-term time pressure. So this was not the case when we first started implementing this. It was a longer time frame. We've deliberately compressed it and taken cost out of the system, and we've got some cost efficiencies that we've been able to bring as well, because we need to get moving.
We have another question.
Another online.
Yeah, another online. So this question is again from Mr. Paves Lagos. He's asking if on your business model is it possible to contract a service with time that is contingent to the savings captured. Hope that makes sense.
So I think the question is about are we willing to explore gain sharing type of arrangements? So fees based on the savings generated.
We just rectifying that.
Basically, he's asking if we can share the risk.
Yeah. Okay. And that's a great question. Our first project that we ever did, we got that question, and we did. We shared the risk. We came up with a formula that put some of the fee at risk, depending on the saving risk, and I'm pleased to say that we maximised our achievement of the bonus under that system. So that's not always going to be the case, but yes, we are willing to look at those sorts of arrangements.
Yep. Thanks, Paul. That's exactly what Mr. Pavis was referring to. Anybody else here?
I really appreciate all these questions. It's great. Thank you. Everyone's been listening too.
Bueno, esto parece ser una herramienta digital donde hay mucha información y permite administrarla correctamente para presentarla y tomar decisiones. Pero también habla de la creación de inteligencia aplicable. Me gustaría saber o que profundizar más sobre ese tema. Si es posible, digamos, que la plataforma tome sus propias decisiones a partir de la historia que tiene el componente y de esta forma de forma colectiva tomar alguna decisión.
Can you summarize that, Gina?
He's asking if the system can take an intelligent decision on behalf of the data entry. I would say that the data, when the data is sent into the system, there is a group of specialists that analyze that information, and those guys are the ones answering. They are taking the decision. The system is telling you, okay, we have seen this, and so what is the recommendation upon all the experience that we have?
Okay, so when this is typical, our software typically manages between 50 and 70% of the data automatically and can make a preliminary recommendation. An analyst looks at the recommendations that go into that sort of queue, and some of those will be passed on because the software, the analyst considers that the software has accurately diagnosed the problem. If the problem and some of the data supporting the problem is more complex, they will start a more deeper dive into that so that they get the right recommendation to the planning group. Does that answer? Yep. So that's an example again of the way that we approach the human plus technology piece. Because, for example, let's say that the problem that is emerging is a slightly unusual problem, and the analyst notices that because a work order has just been completed prior to the problem emerging, they would link those two events. Then they can query the work order, and they might discover that an engine midlife has just been done, and the problem looks related to over-torquing of bolts in the head, for example. So they would make that link because of their experience, as opposed to a computer that is going to find it very difficult to read a work order, a post-work order. So that's now we are putting a lot of effort into automating as much of this as possible, of course. With predictive analytics, we want as much as possible to be done by the computers to keep the costs down. But right now, a lot of the data that we work with is actually quite complex in nature because it's not coming from a simple sensor. It might be, for example, a whole vibration report or a teardown report or those more complex data sets that our analysts have the experience to know what that means.
Anybody else?
Sorry, we got two more questions.
And I know we're going to have to
and we will
break soon because there's a party in the other room, right?
We will just take 2 more questions, and if you don't mind, maybe that would be also useful to you. So 2 questions coming from Mr. Prayer Guamar. He's asking how many equipment simultaneously can be monitored in the software, and also he's asking, besides mining, if there is other evaluations of the software into construction or infrastructure equipment.
Okay, so how much data can be monitored at the same time? Again, there are the only real constraints that. So our software is underpinned by Amazon Web Services, so it scales very wide and quickly if necessary. We're not limited by technology. There are some bandwidth constrictions that we occasionally come up against, particularly in remote areas that only have 3G or less in terms of bandwidth. But of course, there are some limits to our analyst group capability. But the partner that we're working with has a lot of potentially brings a lot of capability in that area. And the second part
is the application to
other non-mining. So actually, that's a very interesting question, because the equipment components is what we typically really build the capability in. And when you break a locomotive down, it's actually let's compare a haul truck to a locomotive. There's an engine and a big transmission, and they're both made by Caterpillar, who own one of the largest rail manufacturers. So, in a lot of instances, we're dealing with components that are very similar. They might have a different work cycle and application, but they're very similar. Interestingly, in the wind market, the renewable energy market that we've moved into, the gearboxes are basically gearboxes that we would find on the ground reapplied up in the air. And the interesting thing is, just as an aside, a gearbox that has a duty cycle of 20,000 hours on when it's bolted to the floor, when you put that up in a nacelle on an 80 metres up in a wind tower, and the whole nacelle is flexing, that puts an enormous amount of pressure on the high-speed bearing on those gearboxes, and they're actually achieving something like 6,000 hours. So it's a very interesting case study. But and in terms of construction, I think that's like mining times 0.7. They're just smaller versions of mining equipment in a lot of cases.
Thank you, Paul, again. I think that's very much it, and I'm sorry for our listeners in different parts of Latin America. We will address your questions internally, and we got 3 more questions, but unfortunately I'm just running out. Yeah, absolutely. So bear with me.
So today we're also very, very pleased. I like to think of the fact that the Dingo has 4 paws in its, on the end of its feet, and today we put 4 paw prints in Latin America. We're very pleased to announce that we have 4 partnership agreements that we're announcing today throughout Latin America. In Chile, we welcome Gino Zandanay to our team, representing us here, based in Santiago. In Colombia, Eric Moncada, and excuse me if I've got pronunciations wrong. We've got Felipe in Mexico and Boris Kimpa up in Peru. So these are people that we've talked with. We believe are people that understand exactly what our value proposition is, and can work with people in their local areas to start the process of understanding our solutions and implementing them. So thank you. Welcome to our team, and their contact details are on the screen for your convenience. And with that, I'd say thank you very, very much. I know it's been a long time. Sorry, Carlos.
Sorry, Claude, to interrupt. Just very quickly, just letting you know, Dingo continues this roadshow through Antofagasta next week, and then we will continue to Lima. We're going to be working in Peru as well as in Mexico. So, if for our listeners here and in Latin America, please do make contact, and we will be very happy to meet you in this roadshow. Thank you very much.
Okay, well, now, as a thank you for your attention, your presence here today, we'll say goodbye to our online audience and thank them very much for their attention and their questions, and I hope this was valuable. And for our group here, we welcome you into a cocktail reception just down the hall. Just go into the hallway and head that way, and there's drinks and some nibblies, and we can get to meet each other. Thank you very much. Appreciate it.